Hey y'all, last video of the year. Here we go. Day 2 of our last unit. Natural logs. So I want to remind everyone, when we're taking the natural log of something, that is just the same as taking a log-based e of something. And so that's important to keep in mind as we're switching back and forth between log and exponential form. Natural log has a base of e. So let's look at this first one. I'm actually going to rewrite this natural log as log base e of 1. And we're evaluating, so I'm going to set it equal to x. We don't know what it is yet. So then I'm going to switch to exponential form. E is our base, the exponent is x, and the answer is 1. That's what we were taking the log of. And so I can tell that x is going to be 0 because anything to the 0 power is 1. So that is our answer for number 1. For number 2, this one looks a little bit strange. We've got a weird fifth root of e to the 4th power. I'm first going to rewrite this as log base e of all of this. And I'm going to rewrite that root 5 and exponent of 4 as a fraction exponent. Since it's a root of 5, or let me write it this way. Since it's an exponent of 4, 4 goes on top, and then this root of 5 goes in the denominator. So that is an exponent of 4 over 5. And we're setting it equal to x. So then I'm going to switch to exponential form. E to the x is equal to e to the 4 over 5 power. And then since the bases are the same, they're both e, we know that those exponents are the same. So the answer for this second one is 4 over 5. Just to really quickly go back over this, the root, in this case it was the 5th root, that becomes the denominator of a fraction exponent. And then if there's an exponent inside the radical, that goes in the numerator of a fraction exponent. So I had to convert those real quick before we finish that one. Okay. In this skill, you'll also just simply need to convert to exponential form sometimes. So for this one, I'm going to continue rewriting these as log base e when I see a natural log. It's x squared minus x plus 17. And this is going to help me. Writing it with a base e reminds me that e is the base of this. The exponent here is 3 over 4. And it's equal to what we were taking the log of, that quadratic. So then we're done. All we need to do is rewrite, do not need to solve when it says convert. But here's one where we do have to solve. I'm going to start solving by just doing some basic algebra moves. So I'm subtracting 5 on both sides. Then I'm going to divide by 5. Oops. To get that natural log by itself. Divide 5. Great. And because e is the inverse of natural log, I am now going to raise both sides to the e power. And this is kind of neat because since e and natural logs are inverses, they cancel each other out. And so we're left with what we were taking the natural log of, 5x minus 8. And then on the right side of the equation, we have e to the 5th power now. And then we're just going to isolate x using algebra moves still. So plus 8, and then divide by 5. And you can leave e in your answer. So we have e to the 5th plus 8 over 5. Just like that. Okay. And then the next skill, we were solving log equations, but before you can actually solve, when you've got multiple logs, we've got to condense first. We're going to start by condensing. So I'm going to remind us of our log rules. If we're subtracting logs, we can rewrite them as dividing the first log by the second log. Oops. Get rid of that highlighting. Okay, so we're going to divide, keep the log base 5, but then I can divide that 9x divided by 8. Then it's equal to 1 still. So now that it's condensed to 1 log, I can rewrite this as an exponential equation. 5 to the first power equals 9x over 8. I'm going to multiply by the reciprocal, 8 over 9. I'm going to do that on both sides. So this cancels out that 9/8 x. So now I have x by itself, and then 5 times 8 over 9 is this fraction that doesn't simplify down. I think if you divide that down as a decimal, you might round to the hundredths place, whatever it asks you on Delta Math. Great. Moving on, more log equations. So a reminder, we're going to use two log shortcuts now. We're adding logs. We're adding 2 different logs. So we can convert that to multiplying the 2 things we were taking the log of. And then we also, we're also going to use the power rule. So we've got this coefficient right outside the log. When we have a coefficient outside of the log, we can move it to be an exponent in the log. So we're going to do 2 condensing moves. Go away. Okay. So the first one, we're going to move that 3 into the exponent. So the coefficient becomes an exponent on the 3. And then we're going to condense that addition so that we're multiplying the 2 things we were taking the log of. Okay, now inside the parentheses, oops, I forgot, this is all equal to 5 still. Inside the parentheses, we can simplify some stuff. 3 to the 3rd power is 27 times 3 is 81. Now we're going to convert to an exponential equation. 5 to the 5th power equals 81x. All right, and then 5 to the 5th power, I wrote that down. Okay, I can't find it. Oh, there it is. 5 to the 5th power is 3,125. Divide by 81. And that fraction doesn't simplify down as a decimal. I don't know if it asks you to round these, but as a decimal, it would be 38 point, oops, that's not 38, that's 83. 38.58. Cool. All right. Moving right along. Okay, so we're going to continue with solving exponential equations. We'll start doing some algebra moves to isolate the base of the exponential part. and this is 0.2. Great. All right. So now I've got my variable trapped up in the exponent, but I can use log rules to move exponents like I did up here, right? That 3, we're allowed to move that outside. So first I'm going to take the log of both sides. E to the x over 4. Okay, and then I can move that exponent now in front of the log. Cool. Now I'm going to divide by the log of e on both sides. So now I've got x over 4 equal to this gross looking thing. I'm not quite done. I'm going to multiply times 4 on both sides. All right, so I've got x equals 4 times log of 0.2 all over log of e. Put all of that into your calculator, and I got negative 4.64, rounded to the hundredths place. Woo, that was kind of a tougher one because of that fraction exponent. Yeah, okay, I'm not gonna say anymore. Just gonna move on. The rest of these are not quite as bad as that one. Again, this next one, we're gonna start by dividing on both sides to get that. We're trying to isolate that part. So I'm gonna divide by 45. And that gives me 5. Then I'll take the log of both sides so that I can use the power rule and move that x out front. Then dividing on both sides, I get log of 5 divided by log of 3. And then as a decimal rounded to the hundredths, you should get 1.46. Ooh, a lot easier than that last one. Okay, and then the last one is also not too bad. All right, so for this one, we're going to, again, start by dividing. Oops, divide 6. And then on that left side, 14 over 3 is what that simplifies down to. Then we've got 3 to the x minus 5 power. All right, so we're going to take the log of both sides again. And that whole exponent, we get to move out front. So that whole quantity, x minus 5. All right, now we will divide by log of 3 on both sides. So we get x minus 5 is equal to all of this, log of 14 over 3 over log of 3. I'm going to simplify that first, 1.402, all of that. And then add 5 on both sides, x comes out to 6.40. Okay. Last topic we did was solving exponential equations, applications of this. So lots of financial applications, right? Person invests $2,000 in a bank. That is the principal investment. And then there's an interest rate, 4.75%. That's our R variable. Remember that we write this as a decimal, so 0.0475. And then it is compounded yearly. That's our N variable. N is the number of times compounded per year. Oh, I think I said yearly. Quarterly. Quarterly means 4 times per year. So N equals 4. And then it asks to the nearest tenth of a year, how long must the person leave their money in the bank? That's our time variable. That's what we're solving for. How long until it reaches $3,500? That's our final amount. All right, so let's fill in some of this info. 3,500. 2,000 is our principal. That's how much we start with. And then our interest rate is 0.0475 divided by 4. N was 4. And then T we don't know. Okay, I'm going to do a couple of things. I'm going to divide by 2,000 on both sides. And then at the same time, if I can get my computer to work. At the same time, I'm going to simplify all of that by putting it into my calculator. So this just divides down to 7/4. And then in parentheses, all of this comes out to 1.012. I'm going to keep 3 decimal places. All of that to the 4th power. Great. Now I can take the log of both sides, so I can get that exponent out, or get that exponent out front, I mean. Okay, so the exponent gets moved to the front of the log. Then I'll divide by 4 log t on both sides. Where's my, there it is. So I'm dividing by 4 because there's a 4t, and then dividing by log because I'm also multiplying t times that log. All right, so the 4 cancels out, the log cancels out, and I've just got t left. Divided on both sides, 4 log 1.012. So I get all of this. And then it asks to the nearest tenth of a year. So that is about 11.7 years. All right. And then it also asks, what if it was the same situation but compounded continuously? So compounded continuously means that we're using the PERT formula, what we call the PERT formula. P of t equals p sub 0 e to the RT. So same values as before. So 3,500 is our final amount. $2,000 is our initial amount. E is the variable E. Our interest rate was what? 0.0475. And then T was unknown. So same start. Divide by 2,000. And now I'm going to use that natural log trick. Take natural log of both sides. And natural log and e are the inverse of each other. So I get the e and the natural log cancel out, and I'm left with what was in the exponent. Then I can divide by 0.0475. So t equals the natural log of 7 over 4 divided by 0.0475, which comes out to about 11.8 years. So slightly faster than quarterly compounding. Cool. That is all. Good luck. You're going to do great. Love you all. Happy end of senior year.